Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Six different models have been published in an attempt to explain the radar signatures of the icy moons that orbit Jupiter and Saturn, said Hofgartner, first author of the study, which was published this month in Nature Astronomy. The way these objects scatter radar is drastically different than that of the rocky worlds, such as Mars and Earth, as well as smaller bodies such as asteroids and comets. The objects are also extremely bright, even in areas where they should be darker. When we look up at Earth's moon, it looks like a circular disk, even though we know it's a sphere. Planets and other moons similarly look like disks through telescopes, Hofgartner said. While making radar observations, the center of the disk is very bright and the edges much darker. The change from center to edge is very different for these icy satellites than for rocky worlds. In collaboration with Dr. Kevin Hand of NASA's Jet Propulsion Laboratory, Hofgartner argues that the extraordinary radar properties of these satellites, such as their reflectiveness and polarization, When you're at opposition, the sun is positioned directly behind you on the line between you and an object. The surface appears much brighter than it would otherwise, Hofgartner said. This is known as the opposition effect. In the case of radar, a transmitter stands in for the sun and a receiver for your eyes. An icy surface, Hofgartner explained, has an even stronger opposition effect than normal. For every scattering path of light bouncing through the ice, at opposition there is a path in the exact opposite direction. Because the two paths have precisely the same length, they combine coherently, resulting in further brightening. In the 1990s, studies were published stating that the CBOE was one explanation for the anomalous radar signatures of icy satellites, but other explanations could explain the data equally well. Hofgartner and Hand improved the polarization description of the CBOE model and also showed that their modified CBOE model is the only published model that can explain all of the icy satellite radar properties. I think that tells us that the surfaces of these objects and their subsurface down to many meters are very tortured, Hofgartner said. They're not very uniform. Icy rocks dominate the landscape, perhaps looking somewhat like the chaotic mess after a landslide. That would explain why the light is bouncing in so many different directions, giving us these unusual polarization signatures. The radar observations Hofgartner and Hand used were from the Arecibo Observatory, which was one of only 2 telescopes making radar observations of icy satellites until I. Thanks for watching. Please subscribe my channel for more videos.